I want to start by implementing logging as a cross-cutting concern, and a really great way to achieve this is using Mediator's pipeline behavior feature. So I'm going to add a new folder inside of abstractions, which I will call behaviors. I'm going to add a new class inside, which I will call logging behavior, and this is going to be our pipeline behavior for Mediator. Here's what the definition of the logging behavior will look like. It's going to be a generic class with a tRequest and tResponse argument. We're going to pass both of these to the iPipelineBehavior interface, and I'm also going to add a generic constraint that the tRequest generic argument has to be a base command. Why am I doing this? Well, I only want to be running logging for my command pipeline. I don't really care about logging my queries. I want my queries to be as fast as possible and return the response to the user straight away, while for commands there is a lot of value in adding some additional information through logging. Let's implement this interface. It exposes a handle method with a request object, which is our command, and the request handler delegate, which is our command handler. I'm going to use the iLogger that is available in .NET to implement logging in this logging behavior, but I first need to add the respective NuGet package. So I'm going to look for logging, and I'm going to install the Microsoft Extensions Logging Abstractions package. So now if I head back to my logging behavior, I can introduce the using statement for the respective namespace, and now I'm able to reference the logger. Let's go ahead and inject it from the constructor, and let's implement the handle method. I'm going to make this method asynchronous, and I'm going to align the arguments vertically so that you can see what is going on. Now I'm going to paste in the implementation for the handle method, and we're going to discuss what we have inside. So first of all, I'm using reflection to get the type of the current request, and I'm taking the name of this type, which is going to be my command name. Then I'm logging an information statement saying that I'm executing the command with this name. After that, I run my request handler delegate, which is my command handler. I obtain a result instance, and I add another information log that this command was processed successfully. And in the end, we just return this result from our pipeline. We also wrap all of this in a try-catch statement, and if an exception occurs, we're going to log an error, passing in the exception and saying that this command processing failed. You can enrich these logs further with more contextual information, like who is the current user, what is the ID of the command if we assign IDs to commands, what is the correlation ID or the request ID, and so on. This is just the base setup for logging in your command pipeline, and it can be further improved. We need to register this pipeline with Mediator, and we're going to go to the dependency injection class, and inside of the add mediator call, we're going to say configuration, add open behavior to register our open generic behavior. We're going to say type of logging behavior, and this is how we can specify our pipeline behavior with Mediator. Now when we send our command, it's going to first enter the logging behavior, run the logging statement, and then execute the command handler before returning the response. One more cross-cutting concern that is important to solve in the application layer is validation. I'm going to use a similar approach to the logging behavior for validation, and we're going to add a validation pipeline behavior. I'm going to be using the Fluent Validation library, so let me go ahead and install this NuGet package. This is a library that allows you to write custom validators for specific objects and then gives you a lot of flexibility with how you can run these validators. I'm going to install the Fluent Validation Dependency Injection Extensions package because I want to be able to also register my validators with dependency injection. With the NuGet package installed, let's go ahead and add our validation behavior class. So I'm going to add a new class, which I will call validation behavior. It's also going to be a pipeline behavior. It has a request and response generic argument, and the request has to be a base command because we only want to be running validation for our commands. Let me add the handle method, and let's see what we're going to place inside of the handle method of the validation behavior. The Fluent Validation library exposes the iValidator interface, we can inject one or more iValidator instances for our tRequest, which is going to be our command. We're going to add the command validators in just a moment, but first of all, in the validation behavior, we are injecting any validators that are defined for this tRequest, or in our case, this is going to be the command. We can inject this from the constructor, and then in the handle method of the validation behavior, we need to run our validation. I'm first going to check if we have any validators defined for this type. If we don't have any validators, let's just invoke the command handler and return from the pipeline. Otherwise, if we do have validators, we need to create a new validation context and pass it our command instance. Then we are going to execute our validators by iterating over them using the select method from the linked library. We're going to call the validate method on each of the validators, and if the validation results returned by this method have an error, we're going to select all of them, and we're going to project these errors into a new validation error instance. We don't have this type defined yet, so I'm going to add it inside of the behaviors folder. It's a simple record with the property name and the error message of the validation failure. After getting back a list of validation errors, we check if we have any errors present, and if that is true, we are going to throw our custom validation exception, which I'm going to define just now, and if we don't have any validation errors, we can execute our command normally. I think validation is a good use case for a custom exception class, and let me define an exceptions folder inside of my application project where my custom exception is going to live. I'm going to add the exception type, and it's going to be using the validation error that I just defined. Because the validation error and the validation exception are tightly coupled, I'm going to move them together inside of the exceptions project, and let's examine what we have on the validation exception. It's accepting an IEnumerable of validation errors in the constructor and assigning that to the errors property. In the validation behavior, we are throwing this exception here and passing it our collection of validation errors, and then we're going to be handling this in some of the upper layers of the architecture. A good candidate is an exception handling middleware in the API layer. Let's also register our validation behavior with Mediator. We're going to run it after our logging behavior, so we're going to define it one line below. I'm going to say add open behavior, type of, and specify the validation behavior type. What else do we need to fully support validation? Well, first of all, we need a validator. So let's define one for the reserve booking command. This is going to be a class which I will call reserve booking command validator. It's going to implement the abstract validator base class, which is coming from the Fluent validation library, and you specify a generic argument, which is the type that you are validating. In our case, this is the reserve booking command, and then if I access the constructor, I have access to the rule4 method, which allows me to define a set of validations that I need on my command object. For example, I can say that the user ID is not empty. Then I can define another rule saying that the apartment ID is not empty. And then I can define a custom rule saying that the start date must be less than the command's end date. So these are some of the validations that I could run on the reserve booking command, and then they are going to be triggered in my validation behavior when my pipeline is executed. We also need to register our validators with dependency injection, so let's go ahead and do that right after the call to add mediator. We're going to call add validators from assembly, which is the reason why I installed the specific Fluent validation library with dependency injection support. All we need to do is to give it the assembly where our validators are defined. This is the application assembly. This is going to scan the assembly and register any validators as an iValidator instance, which we are using in our validation behavior. In this chapter, we implemented the application layer of the clean architecture with the CQRS pattern for our use cases. We used the mediator library to define the commands and queries and their respective handlers. On the command side, we are using our repositories and our rich domain model and domain-driven design patterns, and on the query side, we opted for a more performant approach where we are using SQL queries with Dapper. Lastly, we implemented logging and validation as cross-cutting concerns using Mediator's pipeline behavior. In the next chapter, we are going to be implementing the infrastructure layer.